Welcome back to Nick Does Algos. In this lesson, we'll be covering the Hackerrank easy rated algorithm, modified Kaprekar numbers. Sorry if I'm saying that wrong. I have never heard someone say Kaprekar before. Hope it's coming out right. Okay, so let's first establish what this question is asking and what we need to return with our algorithm. Well, it's telling us what a Kaprekar number is. A Kaprekar number is any number that you take and square it. And if you take the digits of that number, do they add up to the original number that you squared? If so, it is a Kaprekar number. So quick example, you take 5, you square 25, if you take 5, you square it, you get 25. First digit is 2, second digit is 5. What does that add up to? That adds up to 7. Is that equal to your original number? No, your original number was 5. An example of a successful number is 9. So you take 9 and you square it, you get 81. What is 8 plus 1? 1 plus 8. It is equal to 9, the original n. That's a Kaprekar number. Weird caveat in this dilemma, r must be equal to d. What is d? Well, d is the digits of n. So if you had a number that was 3 digits, say you took 10 and you squared 10 and you got 100, the two numbers that you'd be evaluating would be 0, 0, and 1. L would be the first digit, and R would be the other two. Because 10 has 2 digits, R needs to be the right 2 digits. L is 1 digit, it is the remaining 1. What is 10 squared? 10 is 100. That is squared. I can't talk today. 10 squared is 100. You would add 1 plus 0, 0. And that would, of course, be 1. So 10 would not be a Kaprekar number. But okay, let's head over to Replit and start to get to work on an example. Here we've got P and Q set up. The question tells us that P and Q actually give us the range, and we want to find the number of Kaprekar numbers within that range. First example has P as 1 and Q as 100. So let's get to work with that example. First things first, we know that we're going to want to store some numbers and return them at the end. We're going to want to send back the Kaprekar numbers after going through our range. So let's go ahead and set a answer variable equal to an empty array. And then unfortunately, there's no real clever way to do this. You've got to just loop through our whole range. And our range being P to Q plus 1, because we want to include that last number. We want to include 100 to see if 100 is a Kaprekar number. Okay, first things first, let's square our number and set that equal to a variable. We can go square equals num asterisk 2, and that's the quick way to square it. We're actually going to do another step right here to save us some effort later on. We want to set this number equal to a string, because strings can be more easily manipulated than integers can. So let's go ahead now and set that equal to a string. We'll also set a variable of d. D is given to us in Hackerrank. I think if we just printed d in Hackerrank, it would give us the number. But here we've got to hard code it, and we will hard code it as what it is, which is the length of num. And again, you've got to do string to find the length of num. You can't just find the length of an integer quickly like that in Python. And then we'll set another variable of square d, which will be the length of this square. And what would that be? That would be simply length of the square. Okay, so I think that's all the variables we'll need to set up for now. First things first, let's go through our conditions. So Hackerrank tells us that there are 2 conditions for our numbers. If the number squared is either the length of 2 times d or 2 times d minus 1. So we go ahead and set that conditional in our algorithm. So if square d equals 2 times d, or square d equals 2 times d minus 1, then we will evaluate that to see if it is a Kaprekar number. Okay, so let's go ahead and just print these nums to see what we're getting. Okay, there's all the numbers that we're going to evaluate. It looks like within this range, all of them meet those criteria. Okay, great. So now let's go ahead and set our R and set our L. So how can we think about this? Well, we've got a string of square to work with to find our R and our L. We know that R needs to be length D and from the right to the left of the squared number. So if you look at 100, it would be the right two numbers, the two zeros. So because our square is currently in the form of a string, we can go ahead and pluck those numbers to the right like this. Did I write that right? Yes, I did. Okay, so if you're familiar with arrays in Python, you'll already know this, but this means that we're going to start at the end with the colon to the right, means we're going to start at the end, and then we're going to walk back d digits or d iterations. So in that example of 100 or 10 squared is 100, you would take 100 and walk back from the second zero. You would walk back 2 digits because d is equal to 2. 10 has 2 digits, and that would give you 2 zeros. R would be a double zero. And then let's go ahead and get L. So how would we find what L is? Well, L is what's left in the string after we take out D. So simply put, that would be square D minus D. And this one we're going to walk from the front of the number, and we can write that just like that. I think we may need a parenthesis. Yeah, we probably need a parenthesis here. So let's go ahead and put that in. Okay, great. So that should give us our R and our L. Let's go ahead and print these. Let's print R and then print L. Closing parentheses missing. Apologize about that. That should take care of it. Something else missing. What's going on here? Oh, does not match opening parentheses. Got it. Apologies. Okay, I think that should do it. All right. Good. This is what we were looking for. We're printing the number, and then we're printing R, and then we're printing L. And you see that something weird is happening with these original numbers. As you move down, you don't get that, but the first numbers have an interesting problem. And what is that? Well, if you square 1, what is 1 squared? It's just 1. You can evaluate negative d from there, but you can't evaluate 1 minus 1 for the L. So you wind up in a weird scenario. And you may be able to do this in your brain, or it may take some trial and error, but you'll find that the only numbers from 1 to 9 that we need to consider are actually 1 and 9, and from there we can treat everything more normally. So we know that 1 is actually a Kaprekar number. Super weird to think about, but if you look at Hackerrank, it tells us in the, let's just run some code, even though there's nothing there. Okay, never mind. Let's take a look at the example here. We know that 1 and 9 are the only Kaprekar numbers from 1 to 10, and it's after that everything can be handled similarly, but from 1 to 9 we've got some unique cases. So when we have a unique case, we need to indicate that. So if num equals 1, we can just go ahead and answer.append our num. And then we've got the rest of that range that is funky from between 1 and 9. We know that 9 is our next Kaprekar number, but 9 doesn't really follow the same rules either. 9 squared. Does that work? I'm not really sure. We'll start from there though. Because we know that the other numbers will not be Capricorn numbers, we can go ahead and change this to an elif, and we can put this whole or statement in parentheses, and we can write elif num greater than or equal to 9, and those scenarios. Like I said, that's because from 1 to 9, we know nothing's going to happen. We'll include the 1 right there. It doesn't really match these other rules, so we'll give it its own rules. And then 9, yes, 9 we can actually evaluate using these same rules. Okay, awesome. So that should fix this a bit. Let's see if we got rid of those blanks where the L's give us an issue. Okay, great. We got rid of those blanks. Okay, so now let's do something simple. Let's add R and L, because that's what we're actually looking for, right? We want to see if R plus L gives us the num. So let's print R plus L, and you will notice that we get some funky stuff. 009, 001. That should be it, but there's a reason that's happening, and that's because these are actually strings. What we just did when we put R and L together is we concatenated strings. So we actually want to find sums by adding our ints of those. And now let's run it again. There we go. We get all normal numbers. Let's stop printing num. And okay, so there's R and L. We can throw in a conditional statement here, now using our R and RL, and we can write if R plus L equals num, we will answer dot append num. Okay, what do we get here? Oh, we need to go ahead and print our answer. Sorry about that. Okay, awesome. So that is our array of answers. I believe that lines up with our sample output here. It does. 1, 9, 45, 55, 99. Get a match here. But what's weird about this question, Hackerrank does crap like this sometimes. What do they want? It should print the list of modified Kaprekar numbers, space separated on one line in ascending order. Okay. Whatever, making it difficult for no reason. But how can we do this? Well, they're already in ascending order because we're evaluating the numbers from lowest to highest. Don't have to worry about that. But what we do need to do is we need to join them, make them strings, and remove commas. So we can do that by writing putting a space. If we put a space in between these and do a dot join, we can join our answer with spaces. Let's go ahead and print that. I'm pretty sure that'll put us in the right direction. String instance. Okay, so let's do string of ants. That might help us, might not. Let's see what happens. Okay, so gave us some weird thing. What we actually need to do is string num for num in ants. Really what we just did is we wrote a little for loop, and as we loop through the for loop, we change each number to a string, and we join that to our greater string, and that should give us our answer. And there it is. Okay, awesome. So let's go ahead and pop this over into Hackerrank. I believe this should fail, and it's going to fail for a weird reason, and I will be able to quickly show you guys why. Let's pop this over. If that goes over, 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 and let's run it. Should pass these first two, but it's going to fail one very odd test case, which might drive you a little bit crazy. Give it a little while to run. It's pretty slow. It doesn't have the fastest run time. You've got an O of n squared, I believe. Okay, so what happened? Expected output was invalid range. And this range is invalid because if no modified Kaprekar numbers exist in the given range, print invalid range. So we can go ahead and fix this pretty easily. Let's just fix it right in Hackerrank right here. We can put a conditional statement. If len of ants equals 0, print, we can just copy and paste invalid range in the form of a string, and then else we're going to meet our conditions, and we will print that stuff. So that should pass. Run this again. Should take another second or two. And there you go. We pass. Not really a difficult question, kind of just a finicky one. You run into a couple issues here and there to get this working, but at the end of the day, it's some pretty simple code that most people should be able to understand. So I hope you're following. If you have any questions at all, please feel free to drop them down in the comments below. If you enjoyed this video, if it helped you out, please go ahead and hit the like button. This is Nick Does Algos. We cover algos just about every day. If you are also at that point in your coding career, go ahead and hit the subscribe button. You'll want to see the stuff we're putting out on a near daily basis. Thanks for watching, and I hope to see you in the next one.